on Introduction to Simple Harmonic Motion, and this is lesson under Mechanics for Year 13 Physics. So, periodic or cyclic motion is repetitive motion, okay, like the Earth going around the Sun or the hands of a clock. Simple harmonic motion is actually a special type of periodic motion obeying the following rules. It's a back and forth motion in a straight line such that acceleration and hence the restoring force is always proportional to displacement, acting in a direction opposite to displacement. So it's very important when you define simple harmonic motion, you don't just say it's back and forth. You need to refer to acceleration or restoring force and to say that it is proportional to displacement and that it acts in a direction opposite displacement. There are some terms that's used in simple harmonic motion. So the definition of displacement is the distance from equilibrium position. So it's from here to there. Okay, what's the equilibrium position? It's also called the mean or rest position. And at this position, it's when the object is at rest because the forces are imbalanced at this point of equilibrium. Amplitude is the maximum displacement, so distance from the rest position to whatever is maximum displacement. Restoring force. Now this is responsible for simple harmonic motion and it acts opposite to displacement. So if you pull something to the left, the restoring force will bring it back to the right. Okay. Then acceleration, and this is really important because this is what defines simple harmonic motion. And acceleration is always caused by an unbalanced force. The acceleration is proportional to displacement, but it acts in a direction opposite displacement. So if you pull something to the right, the acceleration's to the left. Acceleration and restoring force is always directed towards equilibrium. Okay. Displacement is always away from equilibrium, but acceleration and restoring force are always towards equilibrium. Now, velocity of simple harmonic motion at equilibrium position, the velocity is a maximum because that's where it goes fastest, and at the end positions where it stops and changes direction, your speed is 0. So I've just drawn this little table. This of a spring bouncing up and down in simple harmonic motion. This is the equilibrium position. These are the two end positions. So displacement is a maximum at the end position. So one is positive, the other is negative. Your acceleration and restoring force are both 0 at equilibrium and they are a maximum at the end position. So if you take upwards is positive, your restoring force is positive when displacement is negative, and so is acceleration. And speeds 0 at the end positions, maximum at the middle position. And this is just a diagram to show when speed is 0 and maximum. That's lesson 1.